the last page of this lesson. Question number 11. If the population of Ashmore, Illinois is decreasing by 5.8% per year, hold on, let me just stop, R equals negative 0.058, then by what percent will it decrease in 5 years? So again, they don't even care about these values, the A and the P. So it's 1 minus 0.058, and I'm going to use a Y for years. Now 1 minus 0.058 is 0.942, and that's per 1 year. If we want 5 years, we just put a 5 in front, and then you evaluate. 0.942 to the 5 is 0.742. So after 5 years, that's your new base. But remember, to find a rate, it's base minus 1. That's how you do a rate. So 0.742 minus 1. And you get, sorry, I got distracted, negative 0.258. The negative means it's decreasing, which we already knew. So this is 25.8% decrease. Number 12, a city has a population of 22,456 in the year 2016. A highway has directed traffic away from the quaint old city. Research shows that the population is decreasing every 4 years according to this model. What will be the value of B to the nearest hundredth if the model is rewritten with just a T in the exponent? This problem looks way more tricky than it is. All you have to do is put the 0.95 raised to the fourth together. And you get P of T, 22,456. 0.95 raised to the fourth power is 0.81. And the question is saying, what is the value of B? Right there. These questions are almost more reading than math-wise. And that's an example where the reading and the understanding is trickier than the actual math. So for number 13, a bank's account worth can be modeled by that formula. W of T equals 380 times the quantity 1 plus 0.02 over 4 raised to the 14, where W represents the worth in dollars and T represents the time of years. Algebraically determine the number of years to the nearest quarter of a year that it takes for the account to be worth $500. So this part right here, we're just going to end up rounding. Now I copied part of that formula, and they want to know how long it will take for it to be worth $500. So I'm going to put that there. We have to solve the T or the X is in the exponent, so you know you're going to have to use a logarithm. I'm going to do 2 steps in one line. I'm going to divide by 380, and that gives me 1.32, but this is a huge decimal that I'm going to keep in the calculator. That goes away, and then when I put this in parentheses, I get 1.005 to the 4t. Now I have number equals base to the exponent. So I can put this in logarithmic form, log base number equals exponent. And to get t by itself, just divide everything by 4. And when you put that whole left side in your calculator, you get t equals 13.91 years. Now they want us to round to the nearest quarter of a year, so this would round up to about 14 years. Last question. This is a Newton's law of cooling formula. Make a little more room. a liquid with an initial temperature of 194 degrees. So in this case, they use T with a little I. In our packets, we used a T with a subscript of 0. Liquid with an initial temperature of 194 degrees cools in a room whose temperature is held at 68 degrees Fahrenheit. So they're saying the room temperature is 68. The temperature of the liquid T as it cools can be modeled as a function of the time in minutes. So X is minutes. T, oh, that's not an, is that an I? I can't even see. T sub I is the initial temperature. T sub R is the temperature of the room, and K is the decay constant. If T of 15 equals 102, find the value of K. So this goes back to functions. This is our X value, and this is our Y value, but in this case, T of X represents Y. So I'm just going to fill in everything I have here. This is 102, 194, don't worry, I'm going to rewrite this. R is 68, X is 15, plus the room temperature again. So my formula ends up looking like this. 102 equals 194 minus 168 e to the 15k plus 68. Now, our job is to solve this. Here's our equal to sign. You're looking for this format. Number equals base raised to the exponent. So I'm just going to start using order of operations in reverse to solve my equation. 102 minus 68 is 34. And I'm also going to combine what's in parentheses, 194 minus 168. That? Oh, not 168, my bad. It is 68. I thought that seemed a little big. And you get 126. E raised to the 15k. E is our base, so this 126 has to go to the other side. So I'm going to do the opposite and divide it. That goes away. 34 divided by 126 is about 0.27 e to the 15k. Now, base, exponent, number. Now you can put this in logarithmic form. You can use log base e, or you can use the ln button. Log base e of 0.27 equals your exponent, 15k. Get k by itself, divide both sides by 15, and k equals negative 0.09. And the negative is good because it's called the decay constant. Make sure you practice these problems on Delta Math, and of course, let us know if you have any questions.